Today we are going to look at estimating with our sums and differences using benchmark fractions. So with whole numbers, if I gave you, or even decimals, if I gave you the number 29, you would estimate that to be about 30. The reason being is if we think about our value of this going to be closer to a 20 or a 30, halfway is 25 and 29 is closer to 30, so we would round up, right? So we were thinking about where it kind of fits on whether it would round down or round up. So same thing goes with fractions, but a little bit more precision can be done when estimating. So it's not necessarily just up or down. We are going to estimate fractions to either round to the nearest the whole, the half, or the larger whole. Frequent fractions that we'll be looking at, you can see here, are halves, thirds, fourths, fifths, sixths, and eighths. And this is going to help us start our thinking on how we can use benchmarks to estimate, but really we should be able to have any fraction and be able to estimate that to the nearest whole, half, or whole. So the difference between whole numbers and decimals, we estimated to the nearest wholes. Instead of now with fractions, we are also going to think about that half line if it's ever closer to the half line. So let's do a few practice problems with this, and this is linked, so you should be able to pull this up. Here at school, it's a paper that you are going to have in front of you all the time, and you'll start to memorize it and draw conclusions of what is typical for each fraction, of what it's going to do, and even visualizing it's going to help. So you're going to want this up and ready in front of you. So what if I gave you the fraction 7 1/4? So here's how you can use the chart. You can take and look at the fourths line because we are looking for a 7 1/4. Now this one just happens to be labeled from 5 to 6. Doesn't matter, it's still cut into fourths. So 1/4 is right here. If we look at our options in knowing that this is a 7 1/4, our options are either it's going to become a 7, it's going to be a 7.5, or is it closer to be an 8? Okay. So if I look at the 1/4, which one is it closer to? Our whole, our half, or our whole, or larger whole? Well, it's right in between. It's right in between our two options. So what do we always do if it is halfway? We round up. So in this case, our 7 1/4 is going to estimate to 7.5. Okay. What about this one? 3 4/5. So we have fifths right here. You locate the 4/5. Again, the whole numbers can be different, and we'll have to constantly think about that of, well, what is my estimating options? It's either going to be a 3, because that would be the smallest whole, 3.5, or 4. So 4/5, which one is it closer to? It's closer to the 4. So this estimated answer would be 4. Benchmark 4. What about 2/3? 2/3. So 2/3 is here. Now, what's interesting here is our options based on what fraction we have. We don't have a whole number. So our smallest whole is a 0, or a half, or our next largest whole, which is a 1. Which one is 2/3 closest to? So I have this line here to show you kind of halfway to know if it's going to round down or if it's going to round up. So in this case, which one would it be? You would round down, so it would be a closest benchmark of a half. Okay, see how important this chart is going to be for you? Let's try eighths now. eighths would be 3/8. Okay, so 3/8 is here. What are our options? Be thinking about that. What would my options be based on what fraction I have here? Our smallest whole would be a 6. Our next option would be 6.5. And our next largest whole would be a 7. So which one is 3/8 closest to? It would be 6.5, because it's closer to the half benchmark. Okay. One more, and I threw this one in here so you would realize our benchmarks are not restricted to just what's on this chart. Let's think about this one just logically, knowing parts of wholes. So 2 and 7/10. First of all, we should know our options. We have a whole and a whole, right? Our smallest one and our largest one that it's closest to. And then halfway would be the 2.5, right? If we think about the parts and what makes a whole, what would even be halfway of 10? 5/10. We're over halfway, right? So if we're over halfway, are we closer to 3 or are we closer to the half? Well, our benchmark would be to the 3, okay? Something to think about is if you're ever needing a visual, you can create your number line. Now, showing fractions on a number line is going to be tricky because you have to have equal parts. So if you give more to one side or the other, it's going to make it look like it's closer, but not really. So 2.5 is here, which we know is 2 and 5/10, right? So if I cut this into 4, see how I'm not quite 100% even here? So 2 and 1/10, 2 and 2/10, 2 and 3/10, 2 and 4/10, 2 and 5/10, 2 and 6/10, 2 and 7/10, 2 and 8/10, 2 and 9/10. That looks a little bit closer. So really 6, 7, it's right here. 2 and 7/10. It's really close. So sometimes when we estimate, like we've done with whole numbers, if I gave you 15, you could really say it's 10, you could say it's 20. It depends on how much you are going to compute with the number as well. And speaking of calculating with a number, we are going to have these nice easy wholes in halves so that we can easily calculate with a story problem and being able to do this mentally. Okay, so here are your notes for today. We are doing chapter 1 of Henry's book is 5 2/3 pages long. Chapter 2 is 8 2/5 pages long. So we want to know how much of the book both chapters are. So one thing we're practicing here is what operation is going to happen with the story problem. So if they want to know both chapters, we would be doing 5 2/3 plus 8 2/5. So what I want you to show here is basically what do each of those become and showing me that in an estimated equation using the benchmarks. Okay, so the estimating is telling to use those benchmarks. So we know it's addition, and because it's an equation, we're going to get an answer. So 5 2/3, you'll go back to that chart and say, okay, 2/3 is closer to the half, so that's going to estimate to 5.5. And then 8 2/5, well, if we look at our fifths, 2/5, it's closer to what? The half. So we have to remember that our whole numbers are different on our chart. So it's 8.5 it's closer to. And then we're going to add. So we have our halves make a whole, and then 8 plus 5 as well. So we have 13 and then another whole. You should have 14. Now, because it's a story problem, you should also be thinking about, okay, what is this referring to? And it's 14 chapters. Since we're eventually going to be getting fractions with unlike denominators, like it is, if we were trying to find the actual answer, we should start thinking about what would be a common denominator. In other words, a common multiple. And with a common multiple, meaning the same thing as denominator, we're looking at the 5 and the 3, what could we use to have them both cut into the same amount of pieces? And that would be 15. Okay? Now, another thing to think about is when we are looking at this particular question. Emily's living room window is 2 and 5/6 feet wide. The window in her bedroom is 1 and 1/3 feet wide. How much wider is the living room window than her bedroom window? So if we're comparing these windows, we know it's going to be subtraction. So we have 2 and 5/6, we have 1 and 1/3, and we need to estimate those. When I look at this 5/6, I know that this is closer to a whole just by looking at it. So this is going to be closer to 3, right, than the half, the 2.5 option. Now 1/3, thirds are interesting. So thirds, 1/3 is always going to round up. It's past that halfway line. So there is a 1.5. Now, be careful. This is like what we practiced the day before, where we can't just say we have a common error is students saying, oh, 3 minus 1, that's easy. Okay, 2. And then I have my half hanging out here still. That's not the case. So sometimes when I line it up this way, you tend to see it a little bit better, where I don't have any value to take the half away from. I have to think about using and taking the half away from the whole. We can demonstrate taking the half away from the whole by literally taking and borrowing one and showing that this is still a 3, but now I can take that away. You can mentally do this too, where I just know if I take half of something, I'm going to have another half, right? So you could think, okay, 3 minus 1 is 2. And then if I take another half away, then I'm going to have 1.5 left over. But if you want to go through the steps of visually seeing that, this would accomplish it too. Okay. But remember, the whole point of estimating is to be able to do it mentally. So this should really be encouraged to do in your head. But I understand if you're doing that to get started. Now, story problem. So we are talking about feet, right? So it's 1.5 feet wider. And common denominator, 6 and 3. This one, there's lots of options. Can you do the smallest one? Now, I'm not asking for the least common denominator, but I am asking to see if you can get to the smallest one. So the smallest one would be 6. But you could have said what else? You could have said 18, right? You could have said 24. But really, you're not going to want to go into the range where you have to function with a larger number, especially when it comes to getting common denominators, okay? All right, so this is benchmarks. You will be practicing just blanket, here's some naked numbers, estimating them, and knowing what that estimated answer is. You'll be seeing story problems where you have to show what was happening and then what would be the estimated answer for each, and continuing to practice that common denominator. Make sure you have your chart. I have one waiting for you here at school, so you have it handy in your folder. You're welcome to print it off at home. It doesn't have to be in color. It is just nice to see your options here, and maybe even marking that you have the half as your option, you have a whole as your estimated option, and then that smaller whole as well would be helpful. Okay, good luck, and I look forward to seeing your work.